Last thing for today. We just did a review of simple interest where you put in one amount of money. That's the only deposit you make. Whoever does this is not a very good habitual saver. And at the end of the entire investment, we see how many years have gone by and what was the interest rate per year. And we multiply those and give you one payout, like a bond matures and you get your money. Then there was compound interest, like your credit card. Every month, things change a little bit. Every month, there is a new balance, and that will continue to earn interest, either for you if you are saving or against you if it's a credit card. And again, there is only one principle. We're putting in money just once and watching what happens until the end. So neither of those really is good for saving for retirement. No one is going to save for retirement by putting in money in a savings account of some kind only once and then watching it. If you're saving for retirement, you have to keep putting money into your retirement account. We're going to be simple and assume that people are doing this only once a year. You could do a very similar thing to what we are about to start with monthly, but just to help budget, most people, even if they physically put money in monthly from paychecks and so on, sort of think about it annually. How much are we saving each year for retirement? So we're going to pretend that it's just January 1st. I write a check and I put some money into my retirement account. But we're doing that again and again and again. So we need a new formula. Simple interest, you only had one deposit. Compound interest, you only had one initial amount. So neither of those works for repeated regular deposits. The new formula we'll do a lot more with in a future class. This is sort of your quick get it planted like a seed in your brain. It's called the Sum of Annuity Due formula. They should make a friendlier name, but they don't. And it looks longer, but that's okay. It's actually easier. So let's talk about this. So here's our problem. Someone will save every year on January 1st, $1,200 for retirement. If they get 8% annual interest, then 45 years from now, how much will their retirement account be worth? Now, why is this easier, even though the formula is longer? Because for simple interest, we had that funniness where it wasn't 1 year. It was like days or months, or maybe it's 5 years or something bigger than a year. We always had to do some fidget with the time to make it fit years in the formula. In compound interest, we had to say, what are we doing? Are we compounding monthly with a divided by 12 and times 12? Are we compounding quarterly with a divided by 4 and times 4? We had to make it fit the formula. There's none of that garbage for Sum of Annuity Due. Everything is in years. We don't have to fidget with any number. So yes, the formula is bigger, but that's okay because it's simple to use. And I'm just realizing that I kind of cut the bottom off these big brackets. So I'm going to paste this so it looks a little better. These big brackets, by the way, are nothing special. If I was writing this out by hand, I would use bigger parentheses to say, this is just like an outside where this one is the inside. But when I'm typing, the tradition is, because typewriters didn't have bigger font like this, to alternate back and forth. If you have inside parentheses, then the next layer would be brackets. And if there was a layer outside that, you'd go back to parentheses just to make it a little easier to read. So when you see the square brackets, there's nothing new. It's not a new symbol. It just means outside parentheses. As before, when I see a rate, 1 plus rate, I can just slam a 1 in front of that decimal. I don't need those parentheses. So the 1 plus rates, there's actually no parentheses there. It's only the big parentheses here that I have to keep in the formula. We haven't used a formula yet in class that requires your parentheses key. So this again is, do this one at home with me. See if your calculator works the same way. Don't jump in and try and do a whole bunch of homework problems if you can't get your calculator to work. Otherwise, it's not going to work. Okay, but we can just do this. It is longer, but it is so much easier. Final amount. I have no idea, by the way, why they call this annual deposit every January 1st the principal. Really, it should have a different name, because principal should mean I'm making a single deposit and then watching things change. And that's not what's happening. This is every year somebody is putting in this amount. 8% is 0.08. So I'm going to do a 1 plus trick here and here. And this will be 1.08 times. Now I need parentheses. I'm again doing 1.08. And this time there's an exponent for how many years it is. And then there's a -1. You can't leave out the -1, you'll get the wrong answer. And now we're dividing by the rate. And lots of people will mess up here. So heads up, it's really easy after putting a 1 in front twice to make a mistake and put a 1 here. But there is no 1 on the third time. It's just the rate. There's no 1 plus happening. So that's our setup. And I just put it in my calculator. Since this is a little complicated, I'm going to actually write it out like calculator stuff. So 1,200, use my times key, 1.08, use my times key, use my parentheses key, 1.08, use my exponent key, which could look like y to the x, or it could look like that caret symbol, the one that's like that, minus, and then 45. A very few kinds of calculators require you to hit something here and come down out of exponent land to the normal flow of things. Most calculators don't, so do that if you need to. Anyway, minus key 1, close parentheses, divided by key 0.08, and then equals. So I'm getting $500,911.28. Is that what you got also, if you are with me in chat? So that's a lot. Maybe they can retire off $500,000. By the way, how much of this was interest? It doesn't ask us, but just because I'm curious, They wrote a check from their checking account to their retirement account every year for 45 years. Make that look like a 45 and not a 95. So 1,200 times 45. So 54,000 is what they put in from their own money. Everything else, almost 450,000, was interest. So starting Friday, when we have a little more time, we're going to talk about this more, because something important is happening here. Now that we finally graduated to the big formula and we're saving money each year, not just once, then we can finally get enough interest to retire off. We're going to talk next time about 3 sisters, Cindy, Clara, and Chloe. And they have slightly different plans. They each have 3,000 a year, but some of them spend it on savings or vacations in different ways. And then at age 65, how much do they have? And that will be a little surprising when we see how different saving and spending plans make different amounts at the end. So that's sort of your warm up for when we really talk about Sum of Annuity Due next time.